Hello everyone. Today we're going to learn about sliding window algorithm. This is a simple algorithm and there are many ways to implement it. So learning this algorithm is a good chance to practice, to transfer your thought into code. This tutorial is a part of the data structures and algorithms class. Before having a look at a typical problem solved by sliding window algorithm, we're going to quickly talk about what a sliding window is. A window is composed of consecutive elements of an array or string. And remember, these elements have to be consecutive. So the window gives access to multiple elements at the same time. As you can see in this example, we have access to x, y, z, the three characters at the same time. The window size can be fixed or varies. It really depends on our application of how many data points do we need in our application. In this particular example, we need 3 characters and our window size is 3 and they also fixed. For the sliding part, the window is gonna slide along with a pointer, maybe a pointer with a for loop. Like in this example we have here, our window of 3 is gonna slide along with the for loop from the beginning to the end of the original string. That is our sliding window. A window of consecutive elements, sliding along the string from start to end, so we can have access to multiple elements at the same time. Now let's have a look at our typical problem solved by sliding window algorithm. We are given a string of random length and characters. In our example, our string has 6 characters, x, y, z, z, a, z. And we are asked to count the number of substrings which has 3 unique characters. For example, if our substring of 3 is x, y, z, and it has 3 unique characters of x, y, and z, so that's counted at 1. And we're going to continue to see if we have more of it. By that logic, we know that we need to access 3 characters at the same time. And substring already means that 3 characters have to be consecutive. With this logic, sliding windows sound very suitable to solve this problem. And that's what we're going to use to solve this problem. So we're going to have our fixed window of 3, starting from the first character of the string, which is x. Then we're going to have access to x, y, z. And the unique character of x, y, z is 3. So we found one substring with 3 unique characters. And we increase our count to 1. Next step, we're going to slide our fixed window of 3 to the next index, which is y. Then we're going to have access to yzz. Yzz only have 2 unique characters, so our count remains 1. Next step, we're going to slide our fixed window of 3 to index of z, and we're going to have access to zza. Zza have only 2 unique characters, so our count remains 1. Next step, we're going to slide our window over z, and we have access to zaz. Zaz only have 2 unique characters, so our count remains 1. Then we don't need to slide anymore. So in the end, the number of substring with 3 unique characters is 1. And our time complexity is O(n). Next, let's have a look at our implementation of counting number of substring that had 3 unique characters. And we call them good substrings. We create a good substring array to store substring that has 3 unique characters. Then we're gonna run a for loop to access all elements in the string. Now there are many ways to keep track of our window. You can choose the one that you think is the easiest to remember and implement. Here we're gonna use indexes and a set. We create a set of unique characters of our window of 3. And we know that the element in the set has to be unique. So we check the set size. If it's equal to 3, we have a set of 3 unique characters. So we know our substring have 3 unique characters. Then we save it into our result array. Here we print out the original string, all the substring that we have. And unique substring of 3 can reoccur too, so we're gonna put them into a set to make sure they're unique. Then we're gonna return a unique count of the good substring. And if we run this with our first example, our original string is x, y, z, z, a, z, and our result count is 1. And if we run our solution with this string, this is our original string. This is the list of our unique substring, and there are 12 of them. But notice that BDA got repeated here. That's why we need this step to remove the duplicated good substring. And when we print it out, BDA is no longer duplicated, and our count is 11. Next, we're gonna generalize the characteristic of problems that can be solved by sliding window algorithm. So the characteristic of problem is accessing a few consecutive data points at the same time is necessary. It's a must. If we cannot access a few consecutive data points at the same time, we cannot solve the problem. So it is necessary, or it can be just useful. And the input that we usually see for this type of problem is array or string. And with these input and characteristics, we can use sliding window to solve a problem and have a time complexity of O of n. Next, we're gonna have a look at another example. In this example, we are given a string ABC, ABC, BB. And we are asked to find the longest substring of the unique characters and return the length of that substring. You can see here sliding window has a lot to do with substrings. One way to solve this problem is we're gonna start our window at the first character A, and as we move the for loop pointers forward, so we're gonna keep our window open at B and then C until we hit a character that we already have within our window. In this case, that's gonna be A. And when we hit A, we know that ABC is the longest substring that we have so far, and the count of substring ABC is 3. Then we're gonna remove A from our window. That's gonna give us BCA, and we're gonna keep sliding. So we slide our window to the next character, and we got B. And B actually in our window of BCA. So we're gonna remove the previous B in our window. And at this step, our longest substring length is still 3. Next step, we have CAB, and we're gonna keep sliding the window. This time we have C. C already exists in the window, so we're gonna remove the previous C. That's gonna give us ABC, and we keep sliding. This time we have B, and B already exists in the window, so we have to remove the previous B from the window. And because substring has to be consecutive, when B is removed, A has to be removed too. So that's gonna give our window of CB. And then we're gonna keep sliding. And this time we have B, and B exists in the current window. So B is gonna be removed, and C is gonna be removed too. Then we exhaust our string characters and exit the loop. After all of these steps, the length of the longest substring that we have is 3, and it's gonna take O(n) time complexity, where n is the number of the character in the string. So this window that we have here in this example is called a flexible sliding window. What's flexible about it is the size of the window. So you can see that the size of the window changes along the way when we slide it. Next, let's have a look at our implementation for counting the number of characters of the longest substring, which has unique characters. We initialize the longest substring length of 0. We use string variable for our current substring. We use scene variable to keep track of the unique character of the current substring. Now when we move our for loop pointer, if we haven't seen the current character before, we're gonna put it into the substring, and we acknowledge that we have seen it, and we recalculate the max substring length by choosing the bigger length of the previous substring and the current substring. If the new character is in the current substring, which is our case here, we create our new unique character substring by removing the previous scene character out of the substring and combine that part with the new character. That's basically removing A here. So the string gonna be BC, and then we add a new one here, which is A. So the string gonna be BCA. That's basically what this line for. And then we update scene variable with all of the character in the new substring. Here we lock out a substring so we know what's going on. And after that, we return the longest substring length. If we run our algorithm with the input that we have in the example, it's gonna return 3. And these are the unique substring that we can have along the way. And as you can see, the longest substring of unique characters has the length of 3. And we have 4 of them. And if we run our algorithm with the string of AAB, the longest substring that we have has a length of 2, which is this one here. Next, we're gonna summarize our sliding window algorithm. So it's very likely that if we want to find the truth about our data, and we need to access a few consecutive data points at the same time, and the input is usually string or array, then sliding window is probably an algorithm that we want to try. And the complexity of our sliding window algorithm is gonna be O(n). That is all for today's tutorial. Thank you for watching, and I will see you in the next video.